Hi everyone, I'm Angeline. I'm a machine learning scientist from Georgian. I think we're gonna talk more about Georgian later, so I'll save that for later. Um, Started off in the machine learning space, more in the machine learning in health, and was interested in causality. I joined Georgian, got more into the explainability for investment side of things, and then now I'm working with companies that we invest in and build AI products together with them. So I'm quite a broad scientist. Um, I started more going towards time series, outlier detection, cybersecurity, and then now LLM evaluation. I'll pass it to Ben.
Hi everyone, I'm a machine learning engineer at Georgian. I started my journey off in time series, working in finance. But as you know, everything is time series, even language. So I've broadened my horizon to LLMs, helping our customers fine-tune LLMs and making a reusable toolkit off of fine-tuning libraries to make it scalable, faster. Yes, excited to be with you today.
Hello everyone, my name is Kyryl. I'm a founder and ML engineer at the company ML, where I basically do a consultancy and create educational material for machine learning engineering. I used to work at Georgian for 3 years. That's how I got involved with all of these amazing people in this talk. Yeah, my main focus and primary expertise in engineering, how to deploy ML system large scale, and this is what I have done for last 10 years. Really excited for today's talk.
Hello everyone, I'm Rohit. I'm one of the machine learning scientists on the same team as Angeline and Ben and Kyryl a few weeks ago. I joined Georgian 3 years ago, have been in computer vision until my graduate studies. And ever since I joined Georgian, I've had the pleasure of working across a bunch of different modalities of data beyond images. And yeah, it's been quite the journey, absorbing Gen AI over the last year and a half. And in today's presentation, we hope to bring you some of our learnings, some of our takeaways, and leave you with some assets which hopefully you can use in your day-to-day to make your life easier as an ML scientist. So this presentation is basically from a bunch of ML scientist engineers to a bunch of ML scientist engineers, where we're really just acknowledging the pain of building with LLMs and sharing the most relevant insights. With that, let me share my screen. Okay. Let me know, team, if you can see. Awesome, fantastic. Okay, so the title of our workshop is Leveraging LLMs to Build Enterprise AI. And it's going to be Ben, Angeline, Kyryl, and myself giving you a taste of our learnings. But before that, because Georgian is in the highly regulated financial industry, my compliance team has asked us to say all of this, so bear with me for 30 seconds. This presentation is for discussion and informational purposes only. Nothing presented today should be construed as investment, legal, tax, or regulatory advice by Georgian or any of its affiliates. The statements and opinions of the presenters don't necessarily reflect the views of Georgian. The information herein is for illustration purposes only and may not be reflective of Georgian's investment strategy or the performance of any Georgian portfolio company or fund. Now, just the fact that I read that thing may cause you to ask us, what is Georgian and why are these scientists and engineers reading disclosure statements? So basically, Georgian is a growth stage investment firm based out of Toronto. We invest in typically in B2B SaaS companies as they're approaching the Series A, Series B stages. And what really differentiates Georgian from any other investor, venture capital, private equity firm in the world is the fact that we have an in-house R&D team of ML scientists and engineers, like everyone on this call. And we get the privilege of working very closely with companies that we invest in and help them accelerate their AI and product roadmap. So think of us sitting down with them, having advisory sessions on one side of the spectrum, to being very hands-on, actively co-developing models, deep learning models with them, all the way to deploying them so that they can drive business value out of those models. So with that, I'm going to finally jump in to today's topic, which is using LLMs to build enterprise-grade AI. But before that, a more important question is, how can enterprises use LLMs to differentiate themselves? In today's world, it's very easy to go after an OpenAI GPT model or an Anthropic Cloud or a Google Gemini, where the way we leverage those LLMs is typically through an API call. Well, while that is great, in the long run, that really does not differentiate you from your competitors, because what's stopping your competitor from doing the same? So we think that the way enterprises really differentiate themselves using LLMs or AI broadly is by leveraging these two levers. One is data moat, which is the painstaking process companies have gone through for years to really collect proprietary data via their products from customers, and at the same time, the infrastructure to make the most out of these AI systems after they have been modeled on the data moat that they have. For today's presentation, for today's workshop, we will be focusing on column 1, which is data moat, which can be further classified into few buckets. One is, you could have a lot of proprietary data, but you may still need to generate additional data. Once you have all of this data, how do you typically use them? Well, RAG is a technique with some prompt designing. Fine-tuning is another technique. Typically, in a data science workflow, a one-and-done solution does not work. Typically, it involves a lot of ablation studies, hyperparameter tuning, and we are already talking about scaling experiments, right? You go from fine-tuning one LLM under one set of parameters to a bunch of LLMs under different parameters via grid search. And finally, you need to evaluate each of these LLMs under each of these hyperparameter settings on your evaluation data. And as you can imagine, each of these steps can become very painstaking if there isn't a scalable way to run these experiments and to manage them. This is typically the kind of steps which are involved in developing an LLM application. Try out a prompt with GPT-4 on some examples. Evaluate the results. Well, turns out GPT-4 is too expensive and your manager is after you. So they ask you to try with GPT 3.5 because it's cheaper. Well, you do that and you evaluate the results again. But apparently OpenAI has some privacy concerns. So your manager asks you to try out some open source models. You do that, you evaluate the results again. Turns out that these open source models are not as powerful out of the box, so might as well fine tune. You do that, you evaluate the results again. Well, even though they're small, they're still expensive to host. Can we quantize it? You do that again. You evaluate the results. Well, at this point, if you're contemplating your career choice to pursue ML, you're not alone. But open source models are coming out every single day. A new model is landing every single day. And your manager comes and tells you, hey, there's a new open source model based on the academic benchmarks. It's pretty awesome. Let's try that out as well on the use case. So this is how, your typical experimentation and exploration goes, which is very well depicted by this cartoon. But the question is there a more scalable way to actually do all of these steps while leveraging your data mode. These steps are very painstaking, and there needs to be a better way to manage all of these experiments, all of these steps, and to give you a more holistic picture of which model is working, under what conditions, what are the metrics, and so on and so forth. So with this as the motivation, I'm going to lay out the structure of this workshop. We will cover a few concepts around fine-tuning, followed by a few concepts around evaluation, with the final goal of sharing a reusable asset, which would allow you to fine-tune, do out-of-the-box prompting, as well as evaluate LLMs in a scalable and in a manageable fashion. And with that, I'm going to pass it over to Ben to walk us through some fine-tuning ideas and concepts.
Sure. Thank you, Rohit. So when you think of a data mode, the first thing that comes into mind is, well, to grow the biggest mode, we should bring everything in-house, right? Have our own in-house model, have our own in-house pipeline, have our own in-house data. How hard can that be? Famous last words. I think fine-tuning as a result is where most people start to when they think about reducing the reliance on outside closed source models, and then they try to do something in-house. So in this section, I'm going to go into the basic concepts of fine-tuning, and then the typical methodologies that people employ, and then the advantage of using a fine-tuned LLM as a solution. So what is fine-tuned LLMs? I think most people here familiar during computer vision era. I mean, obviously the era hasn't ended. I'm just saying there was a time where computer vision was at the forefront of the machine learning, deep learning space, where people take something pre-trained like VGG16 and then train it to do some subtask a lot better. For example, identifying like green lights, red lights, and people typically just take the pre-trained weights and then fine-tune the last few fully connected layers to make them much better at downstream tasks. And for LLMs, these analogies still holds. They're almost exactly the same, but the subtask type went from image to text. So you can think about classifying like reviews, extract like a JSON structure from a unstructured PDF file, and then sequence generation. For example, you can do like Q&A agent, question and answering agents that creates like helpful help messages and support messages for users. At this point, you may ask, why not? There's GPT-4o. It's cheaper, it's faster now than ever. Why don't we just use that? Obviously, it comes with a lot of challenges in deploying these in a real enterprise setting. The first, I think, challenge that people observe is that there's a huge privacy concerns, right? Even though OpenAI say we're not gonna touch your data, we're not gonna read your data, there's still a concern where if you're a bank, I don't want to be streaming my customer data and customer queries into a server that I don't control. And second, because it's a third-party API, you develop over-reliance. I think when a lot of people were using GPT 3.5, they have a really fine-tuned, like very fine-tuned pipeline to get the exact answer they want. And the next day, the API changes, the weights changes, and your application suddenly just stopped working. So you're always going to be at the mercy of GPT at OpenAI. If they decided tomorrow to charge you 10x the price, you have to eat the cost. And that's the sad reality. And third, if you use GPT 4.0, everyone else are using GPT 4.0. There's not much of a differentiation between you and your competitors. You can have a much better chain of thought prompt that gives you better results, but tomorrow GPT 5 can come out and then you have to start all over again. And we don't think when it comes to growing a data mode, open source, like a closed source API is the answer for most people. And that brings into the advantages of in-house solution, how that solves the problem before aforementioned. So the first obvious lift is that you control your data, you control your server, you know where the data goes, you know who's looking at this, so thereby alleviating all the privacy concerns you have previously. And because you own the server, you own the pipeline, you can develop a flywheel. For example, you can develop like very simple thumbs up, thumbs down customer feedback, and populate a database somewhere and use that training corpus to make your model better. And as your model start getting better, more user find it useful, more people use it, and you get even more feedback, and that creates a good feedback loop to improve your model, and that differentiate you from your competitor who might just be using GPT-4o, where there's not much of a improvement mechanism unless they use the fine-tuning endpoint, which is a black box. And again, you don't control it. You don't know what's going on. They can be the same model and you don't even know. What are the basic implementation building blocks for LLMs? So the first thing you need to do is to identify use cases. Fine-tuning LLM works really well if you have a very tightly defined expert use case, where for example, like this LLM will just be fine-tuned to answer all the aerospace engineering problems, and I can fine-tune it to do exactly that. And a lot of blog posts and research has suggest that after fine-tuning open source LLMs, even at 8 billion scale, sometimes like most of the time it matches the performance of leading closed source models such as GPT-4, and then sometimes even surpass that. So if you have a narrow use case, I think fine-tuning LLM is a very viable choice. And just to illustrate the efficacy of this, like I have a question in Q&A. So 8 billion scale means 8 billion parameters in the data. Sorry, in the model. And yeah, to illustrate the efficiency of fine-tuning, a lot of people can start see like a very noticeable uplift in performance with just as low as like 200, 300 samples. And obviously, with many machine learning tasks, the more data you have, the better it is. And third, you need to pick an LLM, and a lot of these have very permissive license. There's Apache 2.0, which allows you to do anything, but sometimes there's Llama 3 and Gemma, which there's a specific license where it tells you, well, once you hit like 100, 200 million users, you have to strike a deal with us. But for most startup use cases, these open source models have very permissive license that lets you to modify the weights and to serve it on your own backend and for your own profits, of course. The popular choices are the Llama family from Meta, so Llama 2, Llama 3, and then Mistral from Mistral from Mistral AI out of Paris, France, and then there's multitude of these like further fine-tuned models like Zephyr made by Hugging Face themselves, and these LLMs usually live in 7 billion parameter size, all the way to 400 if Llama 3 will finally release those weights. But a lot of people start seeing like really big efficacy gains in at 7 billion. I'd say anything lower, typically not good. Once you go to 70 billion, the conversation feels more natural and the fine-tuning becomes more stable. And of course, there's hardware challenges to come with that. To host 7 billion models, we generally use G5 X2 Large on AWS EC2, which gives you 24 gigabytes of VRAM, and it costs about an hour, $1 an hour. And to give to lend more perspective into that, typically a fine-tuning job will last any time between like 2 to 3 hours. And then if being diligent machine learning scientists, we want to study hyperparameters, we want to study the prompt design. So we have to run multitudes of tests. And let's say that takes 5 days. And the all-in price of the training would be about $145, which for most startups, it's very doable. It's just 20 days of coffee in Toronto. I mean, elsewhere, I don't know. So all in all, fine-tuning is a very efficient way to leverage these small models and host it yourself and create a flywheel. So now comes into methodology and how people actually fine-tune the weights and change the weights to suit the downstream models. So first thing that coming to my mind is, why don't we do full fine-tuning, like a 7 billion model? So I think 2 problems immediately jumps into my mind is, first of all, like hardware challenges. If you fine-tune a model, 7 billion models at full precision, that's going to take about like 30 gigabytes of VRAM, which now you have to start thinking about, okay, I need a cluster, I need a parallel GPU compute, which further complicates the job. Ideally, we want one GPU, and most of the libraries out there are coded in a manner where one single GPU, it's very easy to get started. So full fine-tune usually is a little bit hard with even 7 billion models. And second of all, there's a more fundamental ML challenges that comes in with full fine-tune. Like as I said before, most people can start experiment around with fine-tuning with 200, 300 data points. And as you can imagine, feeding 200, 300 data points into a 7 billion model, that's like a guaranteed overfit. Like you have a huge model with a lot of capacity to learn. It might pick up on things that you might not even realize and overfit on your data. So full fine-tuning probably doesn't work. So why don't we just train like some of the layers, like the last couple layers, like we do in computer vision models? Well, if you fine-tune the last few layers, what people find generally is that it makes model a lot less stable. So you have last layers that's hyper optimized for your use case, and that kind of introduce a distribution changes in weights. What that means practically is that if I feed in a prompt that's very, very close to my fine-tuning corpus, I may get a pretty good result. But once I start like veering away from the fine-tuning corpus, like putting something completely unrelated, like how's your day, and the model can start suddenly spewing out like random tokens, and that's not a very desired behavior for a lot of these chatbot / large language model applications. But what we can do to make all of this work is to add extra layers, and if we add them very smartly, very intelligently, we can have all the benefits of not being overfit and then use less VRAM, and that's where LoRa comes in. So LoRa is a subset of many various techniques that lives inside PEFT, the parameter efficient fine-tuning. There's like probably 10, 20, probably 30 now of these different methods, but I think most people in the industry rely on LoRa, which basically is you add 2 layers, A and B, into beside pre-trained weights. So instead of training the pre-trained weights, we freeze it and then just train the A and B layers. So once A and B layer gets multiplied together, you get the same shape of pre-trained weights. So then once they add together, you get the unified model that's fine-tuned. You can read about LoRa and its subsequent developments like Dora, Galore, and a lot of these really helpful blog posts. And I wouldn't spend too much time into delving into the mathematical details of these. But resources are out there. There's plenty of like really helpful blog posts. And lastly, to further reduce the memory footprint, people have been incorporating quantization into LoRa. So there's two methods, QLoRa, QA-LoRa, which are just different levels of quantization. So QLoRa quantizes the pre-trained weights and train the AB matrices, so the orange matrices, in the original precision, whereas QA-LoRa just quantizes everything. And of course, there's performance trade-offs, but I think a lot of research suggests in QLoRa the performance kind of remains the same as full LoRa, but you get quarter of the memory, not quarter, the quarter of memory usage for the base layer. And lastly, I think I want to cover like Dora and Galore. These are two recent developments in the LoRa. I think people started asking, how can we make LoRa better? And these are the two that I think came out and then have been adapted by Hugging Face's transformer / the training library, which makes it really easy to also experiment with Dora and Galore. You basically just have to change the parameter. It's very easy. So in a nutshell, LoRa introduces extra parameters, but only just a little bit. I think in a typical configuration, it adds the LoRa adapter layers are just 0.5% of the full model's parameter. It not only allows you to train these models and fine-tune them, but it kind of alleviates all the machine learning and hardware related problems, making fine-tuning much easier for average practitioners. And afterwards, I'll hand it off to Kyryl to talk about the benchmarks and how to evaluate these fine-tuned models.
Sure. Thanks, Ben. So if I summarize this section of the presentation in one sentence, I would say don't trust benchmark, especially open source one, and have your own proper evaluation methodology for your own problem. Of course, you can look at them, your manager come to you and say like, oh, by the way, there is a Llama 4, whatever, but you should never build your business decision around them. And you should have proper evaluation technique, which Angeline is going to cover in details, but let's not rush there and let's go there step by step. Could you go to the next? Thank you so much. So there's a lot of open source LLMs. There's a lot of closed source LLM providers. Which one to choose? Which one even to start from to fine tune? And what kind of pillars you should have in your own evaluation technique. We usually structure business decision, which LLM to fine tune, which LLM to train on top of 4 pillars. Performance. How good is LLM predictions are. It might be anything. It might be classic F1 score. It might be LLM as a judge output. It depends on your problem, and it's always good to have this kind of performance measurement methodology. If you don't have this one, most probably your exploration would not be repeatable, and you might get lost very easily, and it's going to be super time consuming. Once you have performance, there is important consideration for time to train and cost to train, which are somehow related, but time to train is basically how much your engineering department is waiting and wasting their time waiting for a training, because Ben mentioned evolution study might takes 5 days. Multiply data set now by 5, and evolution study would takes several weeks. And of course, the cost to train, because you always can parallelize your training and train it faster. But those two pillars is important to monitor. And last but not least is inference. And inference which is what you're going to stick for a long time. Maybe you're lucky and you can train several times. Business will be happy with this. Inference cost is what you're going to deal day over day. And I have seen many times that products said like, you're good, this cost is fine, don't worry, let's go into production. Never hold the truth. Like like cost of inference always going to get you. And even if you think that like, okay, this cost is fine, if your business is successful, if number of users is growing, cost of inference going to eat you. So this is basically 4 main pillars we usually look when we benchmark our own LLMs. But saying this, there is something you need to start from. And usually public benchmarks are something you can at least get idea of, like what LLMs to look like, and so on. As for today, there is so many different LLM benchmarks. I personally use 4 for my decision making. The first one is LLM Sys Chatbot Arena, which is one of the most popular. And every time you see a new vendor come up and say like, oh, we have GPT-5, oh, we had Claude Sonnet, whatever, oh, we're best in the world. This basically means that they are saying that we are best on this particular benchmark, LLM Sys Chatbot Arena, and human actually just evaluate and said like, okay, this LLM output is better than that LLM output. More precise benchmark is open source, open leaderboard from Hugging Face, where they actually have all open source LLM evaluated on a set of datasets. There is another one called Helm from Stanford, where they go extremely deep into the different property of LLMs. And this is like one of the most depth LLM analysis. And one of the latest one, which to be honest, I got noticed just in July, so like less than 10 days. And Angeline endorsed them in Twitter a lot, is basically artificial analysis AI benchmark, where they have a very nice visualization how to select LLM to start from. And what I love is that apart from all other benchmarks, they put a lot of emphasis on costs. So if you are cost oriented, this is amazing benchmark to look at. But as I said, never trust them, because people who build them might have different incentives. Vendors who submit there's usually a lot of drama involved into open source benchmarks. I'm not sure if you follow vector DB spaces, but just this week there is a recent drama about new retrieval mechanism. So be aware of the benchmarks. Could you go to the next slide, Ben? Ben, could you go to the next slide? Ben, you're sharing. Could you go to the next slide, please?
It's not me who's sharing. It's
Oh.
Rohit.
Oh, okay. Yeah. Okay. Thanks, Rohit. But what about performance, right? Like how performance is calculated on those benchmarks. Usually people don't start from fine tuning; they start from out-of-box prompting. And out-of-box prompting actually can go you pretty much far away with LLM. So would you go to the next one? Like closed source LLM plus very good prompt design give you like decent performance. And usually the sweet spot in terms of the performance, time to train, because you can fine tune those models sometimes, and cost is GPT 3.5 Turbo. Open source LLMs are quite close to it, and there is a series of LLMs, open source LLMs, who are beating 3.5, but they are usually extremely large. What Ben mentioned, that with, for example, Llama 7 versus Llama 70, Llama 70 is much more natural one. And if you go right now on LMSys chatbot arena, you would see that there's only 2 or 3 open source models into top 15, and one of them is from NVIDIA called Nanotron, which is 340 billion parameters. So you need at least, if you're going to quantize it and make it small, you still need at least 16 GPUs to put it for inference, not fine-tuning, just for an inference. This is more than 1 terabyte of GPU memory. So you can imagine that you need a lot of money to serve them. So that might be challenging. So prompt can give you like somewhere, but fine-tuning is usually the much better option. So if you go to the next slide, please. So in our experience, when you fine-tune open source LLM, you can go much smaller. And if your problem is well designed and well defined, you can beat GPT-4 and large models which you use only prompting. Usually our default choices are Quantify, Mistral, and Llama family, and there is many more, but those one are the most distributed one. And as Ben mentioned, with the hardware and with the code base, it's extremely easy and extremely convenient to fine-tune them with our toolkit as well. And bonus point, which people always forget, is that if your output is a structured one, you have a 10 set of classes, or I don't know, you have a token prediction, you are not generating free-form text, don't forget the classic techniques. And we saw this in real life, that sometimes prompting and fine-tuning of generative LLM perform much worse than just fine-tuning simple BERT model. And just don't discount this option. It's still valuable and still very useful. Saying this, I think I will pass it to Angeline. And if there's one thought you can get from this part, is that don't trust LLM benchmark. Make sure you have extremely well-defined LLM evaluation technique, which Angeline is going to cover how to build.
Thank you, Kyryl. Rohit, do you want me to screen share?
Yes, if you can screen share.
Oh, okay, 1 second. So we've talked about fine-tuning, how to leverage data mode, and we had good tips from Kyryl to not jump into LLM and make your own evaluation. Because after all, the benchmarking is useful to kind of know their general capabilities, but it's not the capabilities of the LLM for your data set and for your use case. So I'm going to talk about in this section, like how to evaluate in a scalable way. I think what we learned from our experience is that it's always useful to start with a quick manual evaluation just to assess if it's feasible to do. For example, especially with LLM, because let's say you spend 3-5 hours on fine-tuning and then you're realizing, oh, the output is all garbage. Maybe the problem isn't feasible to begin with. Maybe you need to scope it down, or maybe you need to play around with the prompting more. So make sure to do that before you go ahead into scaling your evaluation. And then once it seems like the LM is performing okay and you want to improve it further and further, that's when we start caring more about curating a data set and deciding scalable metrics so that you can scale your experiments across different models, different fine-tuning configurations, compare it with BERT, compare it with classic machine learning models. And don't forget to always, at the end of the day, do a manual evaluation on top of your solutions, especially maybe the first top 2, just to make sure that it's behaving as you're expecting. So if you see here, there are basically 2 components of scaling LLM evaluation, the data set and metrics. And we're going to talk about the data set first. So what do we need in a data set? Of course, we need input to our application, like input that are representative of your production data, edge cases, high-risk examples, and as well as high-value examples that are coming from top priority customers and you can't get it wrong. And depending on your use case, some desired outputs will be nice or some reference outputs. And how the bigger question, I guess, is how do you establish this data set? You might want to check if there are similar problems on open source data sets online, like in Hugging Face. Or ideally, you can use a historical data that your company has to leverage data moat. And you can easily do this if the LLM application is already automating what's previously done manually by humans. You can manually make a data set, but that takes a lot of time. Or we can also share with you some tricks to use LLM to generate a data set. So there are two concepts that I want to talk about today, which is correct by construction and resource overboard to help you generate data sets with reference outputs. So correct by construction is a concept to design a data set in such a way that its correctness are ensured. So for example, you're making an LLM application to generate API calls from natural language. The challenge is it's easy to know if an API call is valid. You can just try calling it, see if there's an error or not. But it's hard to know if an API call is actually doing what you're asking it to do. So a way to generate data set for this is you can take existing correct API calls and ask LLM to create a description for it, because LLM is really good at creating descriptions and describing code, describing natural language, describing URL. LLM is really good at that. So in a way, you're kind of reverse functioning it. So from your API, use Python or any other function to list out all of the correct API calls that are possible, and then ask the LLM to create descriptions from those possible calls. And at evaluation time, you can use the generated description as your inputs and compare the generated API calls to the original one. And you can apply this concept for so many things, for code generation, for entity extraction, starting from the entities or the topics, and then ask them to generate text. And you can also even use it for RAG use cases as well. So let's say we have this factual question answering task. What you can do is you can sample the document chunks uniformly. And then for each of the document chunk, you can ask LLM to generate questions and answers based on information from that specific section. And then at evaluation time, you can just ask the question and then see if the application answers correctly and if it can retrieve the same document section. So this concept has been useful for us in order to generate data set when you don't have a data set with reference data to leverage. So hopefully it may be useful for your use case as well.
Angeline, this is a very relevant time. So Shimona Narang asks this question. From Georgian's reusable pipeline to experiment various models, do you have suggestions to generalizing input data preparation for different LLMs?
Generalizing input data preparation?
Yeah.
Can you give me like an example of what you mean, Shimona, by generalizing input data preparation?
Can Shimona unmute herself?
Or maybe on the chat. I'm not sure if she can unmute.
Oh, okay. Okay, there are a lot of questions, Angeline.
Oh, really?
Shimona, please feel free to add a bit more color to the question, and Angeline can get back to it. Imtiaz asks this question, Angeline, does a RAG approach reduce the impact of discontinuities arising from new LLM versions?
Sorry. Does the RAG
Approach
approach? Yes.
reduce the impact of discontinuities arising from new LLM versions?
Discontinuity arising from the new LLM versions?
Mhm.
Oh, I see what you mean. Because I see. Because when we introduced RAG, the LLMs. Okay, I see. Because when you introduce RAG, I think what he's trying to say is like, or she's trying to say is when you introduce RAG, we are reducing hallucination, right? Because we're giving the LLM the information it needs to answer the question or the request. So I guess he or she is asking if there's less variation when we change out the LLM portion of it, because the information given now all of the LLMs has more context to answer the question, so they're less likely to hallucinate or less likely to make up different kind of mistakes. It depends, to be honest. I think it is true that it helps with reducing hallucination generally, but I think different LLMs would still come up with different style or different or grab different information from the given retrieval context. At least that's my experience. And some of them would still hallucinate, even if you give them the right context. So yeah, it reduces hallucination, but there would still be a little bit discontinuity if you change the LLM part of it. Yeah, so we'll talk about it when we come to the metrics, but we need to test out the retrieval part of it separate from the generation and the LLM part.
Thank you, Angeline. There's another question which I think is more along the lines of fine-tuning. So we can type that out in the chat. Feel free to continue with your presentation. Okay. Thank you.
Yeah, and maybe to Shimona's question about the generalizing different input format, LLM is really good at formatting inputs. I use it so much for if I get a very, like for example, in a PDF, there's a table and I wanted it to be in a CSV format. I just copy it and then ask LLM, give it to me in a comma separated format, and then they'll give it to me. So if you're dealing with like, oh, I want it all to be in a CSV format, but they come to me in different ways, maybe you can make an LLM application for it to, so that the input are all coherent. And then, yeah, I find that helpful. Okay, so for the second concept that we find really helpful is resource overboard, which is using high-cost solution to generate data and building a cost-effective version of it. You can think about it like shooting a mosquito with an overpowered cannon. How do you apply this? It's very simple. You just use a better model like GPT-4, GPT-4o to generate examples of your desired outputs, and then experiment with a cheaper model. For retrieval, you can do the same thing. You can use a very accurate but slow way to get most relevant context, or even manually check it. Because I mean, human manual checking is the most expensive way of doing it. And then you can experiment with an approximate, faster method of retrieval. So this is very helpful for any kind of chatbot question answering, summarization, or doing analysis, where when you experiment, it seems like GPT-4 is doing really, really well and very close to what you desire, but you're trying to reduce cost, or you're trying to bring it in-house. Okay, so now I want to go discuss about the metrics part of it. So you set up your data set. Now what kind of metrics should I use to assess? There are 3 groups of metrics that we've seen: traditional, LLM evaluation, and property-based metrics. I think the traditional metrics are things that have been around for a really long time, like Rouge. I'm just gonna give a high-level overview of what it means, because the term is being used all the time. So traditional metrics usually measure accuracy of the generated text compared to a reference text. And with Rouge, on a high level, they're actually calculating how many words from the reference are in the generated text. So they're looking more into the recall of it. And in Bleu, it's like the counter side of it, which is checking how many words from the generated text are in the reference text. So it's kind of like mirroring precision recall. And with Levenstein distance, there is kind of an interesting score, which is the minimum number of single character edits, insertion, deletion, or substitution required to change one word into another word or one string into another string. So the challenge with these traditional metrics is they need a reference text, but they also measure exact similarity. So if you have synonyms, they won't catch it. They would think it's different. If you have two words that are the same, but they're talking about, in the context, they're talking about different things, then they wouldn't be able to catch it as well. So some people also use BERT score to combat this, which is just cosine similarity of the BERT embeddings of the generated text and reference. Just a warning that this captures more of the semantics of the topic rather than the exact accuracy. So for example, if you say the stock price goes up and stock price goes down and compare the cosine similarity, it's like 0.9999 because they're basically talking about the same thing. But the content of it is actually different. And there's another score that people talked about, which is perplexity, which is an aggregation of the probability of each token. And this reflects confidence of the LLM and not necessarily the accuracy of it.
Angeline, there's a question which I think is very typical in this section, which is Andres Kyryl asks, what is the success criterion for a large language model? It's very open-ended. What are your thoughts, Angeline?
The success criteria for a large language model is, I think if it's doing what you're asking it to do or what you're expecting it to do, I think that's a success. But that's very general, right? So you need to kind of break it down into what does it mean that it's doing, that it's doing what I'm asking correctly, like different other than exact accuracy to the reference output, you need to kind of think about different dimensions or properties of the output that you're looking for. And we're actually gonna talk about it more as we go through the different groups of the metrics. Thank you for the question. Yeah. Okay. So the second one is LLM evaluation. Specifically like LLM evaluating other LLM. Sorry. And this allows for evaluation of open-ended responses where reference answers are optional. And how it works is you have your application, right? So your prompt, your LLM, response to end user. And then you have another LLM, the evaluator LLM, that takes in the prompt and a response, and they have their own prompt. And they evaluate based on the prompt and the response of the original application. What's nice about this is you can approximate human evaluation as long as you have the right prompt. And back to Andre's question, like, but you have to define these for the LLM. For example, are you looking for creativity? More important if you're like doing like a copilot for writing, for example. Are you looking for helpfulness of answer or readability? Are you looking for groundedness? So it's something you need to ask the LLM to do. And it can be used for evaluating criteria specific to your use case, like style, policy alignment, and things like that. There's this like nice out-of-the-box LLM evaluation that I really like called Ragas, and they have nice out-of-the-box LLM evaluation metrics for retrieval and generation evaluation. Specifically for generation, there are these two metrics that are quite useful. The first one is answer correctness. A lower score in answer correctness either mean the answer is incomplete or it contains redundant information that is not relevant to the question. And how do they calculate it is they use an LLM to reverse engineer artificial questions based on the generated answer. And then they compute the average of the cosine similarity of the original question to each of the artificial questions. So they're using more LLM calls. It's not just like one direct, like, is this answer correct? Which is very general. What do you mean by answer is correct? But they're actually seeing what kind of information are being answered in the complete answer and then seeing how it's relevant to the original question. Another scoring metric that I like is called faithfulness, which is checking factual consistency of the answer given the context. And the way they calculate it is they use LLM to identify individual claim or fact given by the generated answer, and then they cross-check each claim with the context. So for each claim of the answer, they ask the LLM, is this in the context, yes or no? And then basically the score is the number of claims that can be inferred from the context versus the total claims. So this gives you a more like, not just, so LLM evaluating other LLMs is really bad at giving continuous metrics. It's usually better at categorizing, like binary, like 0 or 1, yes or no, or maybe 3 or 5 different categories. But it's really bad at giving you fractions. They would hallucinate a lot. So this is a way to use it that it would give you a meaningful scoring. If you don't want to use LLM, you can also use pre-trained language model. Hugging Face Evaluate library make this really easy. You can just load any model that is in Hugging Face and then do compute. For example, for toxicity, it's just a matter of 2 lines, and similar with bias and sentiment. Okay. So of course, some challenges with this method is the correctness of LLM evaluation is not guaranteed. We know LLM is just a probabilistic model. It on a high level. So and it can be non-deterministic. And generally, LLMs cannot give accurate continuous valued response. I mentioned this earlier, but there's some workarounds. And arguably, you need to use a better LLM to assess your current LLM application, and that can be expensive. The third class of metrics I want to talk about is an alternative to LLM evaluating other LLMs, a cheaper alternative, may I say. So I'll talk about this in an example. Let's say you have a summarization use case. Think about, what do we want out of the summarized text? We want it to be concise, and we want it to capture main points of the original text, not just copying the first sentence or copying the last sentence. So how do we assess this? For conciseness, we can just check whether the generated length is less than the input length. We don't need to ask LLM, is this concise? We can just check it ourselves, or you can just check the number of words. And then for capturing the main points, you can check the similarity of the first sentence with the generated summary, or the similarity to the last sentence. Or does it contain keywords from the middle of the paragraph? So there are easy ways to check for whether the summarization is fulfilling the properties that you want. So our recommendation is to think about your use case, think about what kind of properties you want your outputs to have, And if there's an easy way to measure each of these property without using an LLM. So we give you a flavor of different kind of evaluation. Our recommendation is that it is difficult to aim for robust evaluation. And generally, that's why we do not aim for fully automated evaluation. We always recommend to do some manual evaluation still at the end of the experiment. But to make it easier, you can combine different metrics, look at different properties, and when possible, try to think of deterministic ways to assess your output. And definitely evaluate each of the application blocks separately. Well, if you are experimenting with fine-tuning, keep the retrieval part static. So you're only playing around with the fine-tuning aspect or the generation aspect. Yeah, and don't skip human evaluation. Okay, so that's all I have for the LLM evaluation. I'm gonna go through a small demo of what this would look like in a rack setting. So I just have a question. It would retrieve the most relevant block chunk and then pass the question to the LLM with the retrieve context and give you an answer. There are 4 notebooks. The first one is setting up the application. The second one is creating the data set. The third one is defining the metrics. And the fourth one is where we actually evaluate. If you want to follow along, we have, one second. We have a repo here. Okay. Oh, sorry. And let me stop sharing. I'll reshare my VS Code. Okay, I think people can see. Yeah. All right. Okay, so there are 4 notebooks. If you look at the README, we have instruction on, we have instruction on how to set up the environment. We have the requirements.txt here, or if you want to use poetry. And don't forget to copy this env template and put in your own OpenAI API key. Okay, so setting up the LLM, I'm just using a Q&A example from LangChain to make it easier. And so we are loading the OpenAI API key here and then just importing the libraries. I'm using a web-based loader to get the blog from the internet on agents. And then I'm just using a very simple character splitter, dividing it every 1,000 characters into one chunk, and then putting it into a Chroma vector database and pulling a prompt, rack prompt. That's a very generic one. It just says like, you are an assistant for question answering task. Use the following pieces of retrieve context to answer the question. Yeah, if you don't know, just say that you don't know. So I'm just setting up some LLM with the chat OpenAI, just using the GPT 3.5 Turbo, or if you want to use your own model, you can just uncomment this one. And I'm setting up 2 blocks. The first block is a retriever block, and then the second one is a generative block. And the reason why I do that is because I want to evaluate the retriever block separately from the generative block. So it makes it easier for the example. Yeah, so if I ask a question, what is task decomposition? It would give me these contexts, and then the generative block would answer, oh, it's a technique that breaks down complex tasks into smaller and simpler steps. So it looks good to me. So I'm gonna make a data set now. 1 second. Okay. So I'm just setting up the application again in this notebook. And then I would just want to look at the splits. So these are the different splits. So we can see, for example, this one talks about tree of thought. This one talks about short-term memory. Of course, there's a lot of ways to improve the splitting, maybe by paragraph or by sections. And it seems like I have 66 splits now. And what I'm gonna do next is to set up a chain to ask LLM to create question and answer pairs per a document chunk or per split. And I'm doing it with a Pydantic output parser to make it easier. So I define a QA example. I want this to be my output. That it should have a question and it should have an answer field. And then I can add a validation that the question ends with question mark. And all the prompt I gave is given the following text, generate a set of questions and answers about the information contained in the text. And I'm just chaining them together, the prompt, the LLM. I'm using GPT-4 now because I want it to be good quality, and the parser. So I guess I'm combining the correct by construction and the resource overboard together in this example. So let's say the first split. Let's ask the chain to make a question from it. Okay, so the first question that they generate is, what is the core controller of the autonomous agents mentioned in the text? And then they say LLM, which makes sense to me. And then I'm gonna go over a for loop over all the splits and generate the question for each one. It's gonna take 4 minutes. So it's gonna take some time. And then if you wanna generate negative samples, so that these are, these are questions where the information is not contained in the text. So I just wanna make sure that our model is not hallucinating, that we always have information for each question. So I do that a few times. And then I'm saving them in a CSV file that I put in the notebook. So you can skip running this if you'd like, in generatedqa.csv. So it would look like this, where we have the question, the ground truth answer, and the ground truth context. That's the right context to retrieve. Okay, so now let's move towards the metrics definition. So there are two things we can measure. We can measure whether the context retrieve is good and whether the overall answer is good. For this specific example, I want to focus on assessing the answer itself and keep the retrieval constant. So I'm going to look mostly into these metrics, Rouge, which we talked about, Levenstein ratio, faithfulness and answer correctness from Ragas, and also toxicity. Yeah, and as you can see, I think with LLM development, a lot more effort is needed for thinking about the problem, the properties that you want to evaluate. But to be honest, once you're done with that step, the coding itself is quite simple. So for Rouge, we only need 2 lines. For Levenstein, we can just import from the Levenstein library. And then Ragas, just a matter of putting it into the format that it needs and then evaluating it. And toxicity is also quite simple. And then running the app, I'm just gonna give an example of running the evaluation. So let's say I have generated data set. I went over each data set and the generative block and pass in the correct context as if it's already retrieved. And then I'm just gonna run the evaluation over each of them. I'm only doing it for the first 2 rows just to keep it short, but feel free to run it over everything. Yeah, I already ran it earlier, so we can also see this would be the example of results that we have. Okay. Let's see.
Thank you, Angeline. Feel free to take a look at some of the questions. There's a lot of
Oh,
questions, which is fantastic. Like we're really enjoying answering all of them. But there are
okay.
some questions which haven't been marked with a blue tick, which I think you would be better suited to answer. But just wanted to let you know that there are a lot of very good questions that have come in.
Oh, that's awesome. Thank you. And yeah, I think I want to end with this. So this is nice example for like one set of LLM prompt, but imagine you have to do this over and over with zero shot, few shot. You want to try fine tuning LLM, the different models, and then different kind of LoRa configs. It gets a bit annoying. While it is a bit more scalable than doing manual evaluation, it's not completely scalable. You still need to run it multiple times. So I'm gonna pass it to Ben to talk about how we can better scale this.
Thank you. Let me share my screen. Hopefully no curse of live demos. I've been having some of those lately. Okay. Oh, infinity mirror. Okay, I'll just switch window. Hopefully you guys can see. I think as we have alluded in the chat, we have developed a LM fine-tuning toolkit that takes care of all the pipeline for you. From fine-tuning, choosing a model, the prompt design, to inferencing on the eval set, to testing. We have a pipeline kind of figured it out for you. All you need to do is to define a YAML config, and that's pretty much all you need to do. We'll be pasting the link to the chat, and we'll demonstrate how to install and then run a sample job for you, and then we'll demonstrate how easy it is to extend the testing part. For example, to incorporate a toxicity score for all of our outputs. So yeah, without further ado, let me copy the install command. We have a empty Lightning Studio environment, which Lightning is really useful because it gives you really good GPU ready torch setup environment out of the box, and with no setup required. And this is not a sponsored message, I swear. So with this, we paste in our install command, pip install LM toolkit. So it will download all the requirements. And with this, the next thing we need to do is to install Flash Attention. Because how the Flash Attention library is structured, you have to install them separately, unfortunately. We'll do that as well. So with this all installed, we need to have a default config file. We have made it really simple. We have a command for that, lmtune generate config. You enter this, and after a few seconds, it will have a default config ready for me. You can see all of the training parameters, the prompt, everything lives inside this config.yaml file, and you can define your model here, your quantization level.
Ben, can you zoom in a bit?
Yes.
Yeah, awesome.
It's getting a little cluttered. You can define your LoRa parameters, your rank, your alpha, and then training, the batch size, the the inference parameter, the temperature, everything. And even for the testing part, you just have to tell the YAML which metric to test. And the available tests are all living inside this repo where you can check at your own spare time. But for now, we'll just enable everything. It's enable everything by default. So for example, if you don't want word overlap, we just comment it out. Easy as that. And this is like pretty basic, useful default already. But in our case, let's fine tune on Angeline's generated QA dataset. So all we need to do is to do CSV path and give it the path, which is generated QA.csv, and prompt. I have it copy and pasted. 1 second. Indent. So we have a question injected with a curly bracket here, and then the ground truth context. And then lastly, for the output, the thing we're trying to predict, we do ground truth. I think that's the column. Just making sure, question, ground truth context. Okay, so test size, let's do 66. There's, I think, 76 in total. So then that should be trained. Wait a minute. We're only going to be training on 66 pairs of data, and then we're going to do vibe check on 10. We're just going to use OPT 125. Oh, you know what? Let's use Mistral, because why not? There's only 66, so it should be really fast. We use Mistral 7 billion here. And what's really useful is this has ablation study feature baked right in. If I wanted to experiment on more ranks, so I just have to turn this into a list. And then now the script will automatically ablate over rank of 32 and rank of 64. But in our demo, let's just do a single experiment for now. So with this defined, I'll open up my terminal again, clear it out, LM, and then to run this, you do lm tune run config. And now I will show you how, this is really max zoom level, so you can't see the goodies that this provides, but it will tell you the question, ground truth, and how those columns are injected into a prompt. And then it will show you fine-tuning progress. Right now, we're only running one epoch, and I think in one iteration, it will cover all these 66 examples. So I think this should be pretty quick, like 20 seconds.
I think I'll take this moment as it's fine-tuning to, oh, there you go.
Oh.
Complete.
And then this will load and merge the weights, and then perform evaluation, or so-called vibe check, where we compare the generated text versus ground truth. Yeah. Oh no, it says I don't know, but so you can see it's already producing some really helpful text. It says I don't know, but I think it does know. And obviously, this has only been fine-tuned one epoch for the sake of speed. So the generation result might not be as good as if we were to run it for a couple more epochs.
I think the point here that we would like to share with you, everyone, is at the very start of the presentation, we promised all of you that we will try to distill our takeaways, the struggles that we have had to face when trying to fine-tune a lot of these LLMs, when trying to make sense of how to manage different prompts, how to manage different hyperparameter settings. And the answer to that, to those situations, is basically this toolkit, where Ben, if you once again go to the config, if you can. So everyone, you can think of the config as an end-to-end place where you can define the prompt. If you scroll up, Ben, at the very top,
Yeah.
you can define, the prompt that you want to play around with. And the beauty is you can directly over here, if you see within curly brackets, we have mentioned some words, question, and then ground truth context. These are basically column names, which are available in your CSV and should be ingested in your input prompt. So as opposed to you having to manually create those instructions, create those prompts, we have taken that bit and automated with this step where you can add whatever instructions you want to add in your prompt. And then you can mention the column names that you think are relevant, mention the output column name, which is what the model should learn to generate. And then, your typical ML configuration setup, which is what should be the training size, what should be the testing size, what should be the seed that you want to run the experiment with. Then you get to the model part where you're defining, okay, now that I have defined the data bit, let me go and mention the LLM that I want to play around with, or the LLMs that I want to play around with. Ben showed here the example of Mistral, but just by adding a square bracket, Ben, can you just show that? Yeah. Just by doing that, you're able to now ablate over not just Mistral, but a Llama 3, a 7 billion, a Zephyr 7 billion, right? Yeah. Ben, can you go back to the config? It's okay.
Oh, sorry.
Yeah. So this is where you take care of the model bit. Next comes LoRa. It is a topic which we all talked about. In LoRa, you have a lot of parameters that you can play around with, including the rank, the alpha. These are basically values such as the learning rate, the number of epochs that traditional ML requires to be configured. In the world of LLMs, LoRa has a bunch of those knobs which can be controlled. And once again, we can add square brackets to add not just one value of R, but a bunch of values over which we want to ablate. And all of that is happening in this one config file. As you scroll down, you have your training configurations where you can define the batch size, the eval size, all of it, the learning rate. If you keep scrolling down, then you have your training bit, which is taken care of. Next comes inference, where you can mention the temperature, you can mention the top P values. These are values which you may have been familiar with if you have used OpenAI's API, where you can mention these values as well. And then finally, to close this thing off, to close the end-to-end paradigm off, we have the tests, meaning you have your data for a specific use case. You have defined a prompt or a collection of prompts. You have defined a collection of LLMs. You have defined a collection of LoRa hyperparameter settings. Now you do the fine-tuning job, you do your inference. Now you would want to evaluate each of these LLMs on certain set of metrics. And that's where the tests come into picture. So with that, Ben, we can go back to the terminal and see what we have managed to get at the very bottom.
So if you scroll to the bottom, it'll tell you the test results for these different metrics and the summary statistics. It's even more is that if you go into the specific experiment folder, you'll have everything you need to replicate and evaluate this experiment. You'll have exact copy of the config you use. So you can just copy and paste elsewhere and then run config.yaml and we'll give you the same experiment. And then dataset will be a pickle file that you can load via Hugging Face. You have the inference results on the eval set will give you prompt, ground truth, and predicted. And then, of course, there's weights. With weights, you can just very simply set up a inference endpoint pretty quickly. I think if you have time, we have another Lightning Studio to demonstrate. And finally, the QA. It will have all the scores for each evaluation row that you have tested. You'll have Jakarta similarity dot product, and you can verify the results for each of your training evaluation samples.
Ben, because we have only 3 minutes left, I think we can just say that if you go back to the slides, Ben.
Yeah.
So I think in the last 2 minutes, we wanted to share that this is the diagram that you can take away. If there's one slide that you have to remember from this presentation, we basically encapsulated the fine-tuning bit, the evaluation bit in the toolkit, which Ben demonstrated. And if you go to the next slide, Ben, and that's where the fine-tuning toolkit comes into play. Feel free to clone the toolkit for your own use case. We could not cover that in the interest of time, but what makes the toolkit special is the extendability feature of it, meaning that it's going to live for as long as new LLMs come out, for as long as new evaluation metrics come out. We have modules that can be extended. So tomorrow, if there's a new kind of helpfulness or toxic measuring metric that comes out, the toolkit can be extended to incorporate that. This is to make sure that you are able to get the benefits of the toolkit while at the same time extending the toolkit for whatever special use case you're going after, which may have special LLMs or special metrics that you want to compute. And I'm going to share the link of this repository. Owing to compliance, I'm not allowed to ask anyone to give stars to this repository, but I think we can all agree that stars are important for a repository to thrive in the open source community. So I would welcome all of you to check out the repository, shower some love to the repository. And we are always looking to join forces to bring this repository to the entire community. So we would love to join hands with you and collaborate together. With that, I'm going to quickly share that we have an event coming up on Thursday, which is tomorrow, from 5 through 8 p.m. It's going to be a 3-hour hangout of practitioners, ML practitioners, developers in Toronto, founders in this space. It's going to be a very cool socializing event. Food and drinks will be served. We'll be talking about all of these topics that you see on the slide. And this is the QR code which you can scan and register. It's a free event. Come along, bring your friends along with you. It's going to be a fun evening of learning and socializing. And with that, I'm going to stop talking. Angeline, Ben, Kyryl, if you guys have any last words.
Yeah, if you want to learn more about LLMs, Gen AI space, we actually have a monthly transfer learnings webinar where we chat about this. So if you scan the QR code, there's also a link to join our community there.
Awesome. Ben, Kyryl, any last words?
Good, you covered it.
Good. Awesome. Well, thank you so much, everyone, for joining the session. We really appreciate all the thoughtful questions that you have asked. I hope that we have managed to answer all of your questions. If not, again, feel free to drop by tomorrow in the event. We can chat more. Or feel free to leverage the TMLS app, the VOVA app, to reach out to any one of us, and we can entertain your questions even more. And as Angeline mentioned, please join the monthly webinar sessions that we host at Georgian. So once again, thank you very much for your time, and I'll see you guys later. Bye.
Someone asked for the address of the happy hour. If you register, it will be sent to your email.
I think it's near Salonis Market.
You don't. Yeah, we don't want to. Yeah, there you go. Some suspense. Awesome. Thank you, everyone.
Thank you.
Bye, everyone.